This is the continuation of the previous video, and I'll be using the same card we used in the previous video. And we have seen the previous video, we learned how to authenticate the Ultralight EV1 tag, and also we have seen what happens when you exceed the number of wrong password. And in fact, this tag is broken, is completely locked, so you cannot write any further. So in this video, I'm going to show you the various commands that are used by ACR122u and some information to the developers who would like to build a software around ACR122u. So before I do that, there's one thing I did not discuss in the previous video, that is the counter functionality. So you have to read this section 8.7. So what it basically says here is the initial value of the counter is 0. So initial value means when you buy a new tag, the counter is set to 0. And there's also important information here. It says the counter is not part of the regular NVM, the non-volatile memory, and hence it is not addressable using a read or a fast read or a write or a compatible write. The actual value can be retrieved by a separate command called read count, and you can increase the value by a separate command called increment count. And it also mentions about what is called as a tearing event, and I briefly mentioned what it is. It is the time when somebody takes away the card from the field. So this is handled very well in the tag, so you will never have any inconsistent data in the counter. And it also says the maximum value you can put is all 6 FFs. So there's nothing but the counters are 22-bit numbers, it's not 32-bit. So the last byte of the counter is not used. So I'm going to just show you how to do the read and write. And remember, this tag I cannot write because we have exceeded the number of wrong password. However, but keep in mind the counter operations, incrementing or reading, is nothing to do with all these password protections. See, this is, you cannot protect the counter. It's always open. Anytime you can modify and anytime you can read. So here in the tab, I've got 3 tabs here in the screen, sorry. Counter 0, counter 1, counter 2. So I'm going to read. If you hit this button, I'm going to read it. So we have not changed the value of the counter, so the initial value is all zeros. I'm going to increment this counter by 1000 and write it. So we are able to write. So likewise, you can use this counter to increment anything. In fact, there are 3 counters, and you got more flexibility here. It all depends on the application you're trying to create and how do you use these counters. I think that is all about the counters. So we are going to see now what exactly is happening behind the screen when we start read and write. So I'm going to reactivate the tag. Probably I can start this again. So here in the tabs command, you're going to see what's happening, and this is probably useful for the students or the software developers or or those of you who are interested in programming this ACR122. So when I click on activate, now there is a feature called Autopool in ACR122u. What it does is, as soon as you place the tag on the reader, it will automatically activate the tag. It will automatically read the UID of the tag. So all these commands are explained in ACR122u document. Now I'm sending the first command. This is a AAPDU, and these are the PCC commands. And this is the command I send, and this is the reply you get. So there is a command called get data. When you pass the parameter 0, you get the UID, and this UID is what I'm showing here. The next thing is the documentation says this is the command to get the ATS, but this Ultralight EV1 doesn't generate any ATS, so you would get this kind of a error message 6881. And from this point on, the most important thing you have to keep in mind is you have to set the Autopool off. Otherwise you cannot successfully run the PN532 commands. Now this command is, I mentioned this in my previous video, there is a command called get version. If you look in this documentation and search for get version, so the get version command, see, in order to send these low level commands, there is no equivalent of PCSC. You have to send the actual command using a kind of a APDU. See, this is an APDU as well, because the class of the APDU is a FF, and followed by this is the command, the PN532 command. In fact, these two are the actual commands. No, not of this, sorry, the 60 is the actual command. If you look at the documentation, so this is the command, it's very well explained here. So get version command returns you information about this tag, and the command code is 60. So how do you pass 60 to the tag? So I know that there's a 60 here. All other things before that, they're all required. So this is a PCSC APDU structure to send the raw data. This also called, if you look at the documentation, it's called as a direct command. So I'm just going to briefly explain what it is. So FF is the name of the class. If you remember this structure of the ISO commands, so any ISO command has got the class followed by the instruction followed by the parameter 1 and parameter 2 and the length of the command, and this is the command length, all the remaining commands. Okay, so if I map what's going on here, the class is FF, the instruction is 0, the parameters are 0 and almost 0, and I'm passing D442603, so 3 bytes I'm going to pass. So the length of this command is 3, so LC goes here. So this is a very standard structure, and there are so many documentation about the ISO. Look for ISO, I think it's 7816-4, or in general, otherwise just search for APDU. So this is the command APDU, and the response you get is called as a response APDU. So they're a very simple concept. So here, so we are trying to send the direct command to this tag in terms of PN532. I've got so many videos on explaining how to program PN532. Please take a look at them. So the D4 is the command direction. This is what I'm speaking now is about PN532. The 42 is called as a in communication through command followed by the actual command. So when we send this command to the ACR122u, ACR122u finds out what type of command is this. It knows that FF followed by all zeros means it's a kind of a low level command. So this is passed on to PN532. So if you don't know what's PN532, this ACR122 reader writer is based on a PN532 chipset. So the PN532 is a chip which is a RFID reader writer chip manufactured by NXP. and the output of that is, so the output starts from here. In fact, output starts from here. The actual output starts from here. If you look at the documentation, it says the output is a 8-byte product information. Now if I forget the last 2 bytes, if you ignore this, because this is the response code called SW1, SW2, from here you got 2, 4, 6 and 8. So these are the 8 bytes of data you get, and the first 3 bytes are the standard response bytes for any PN532 command. If you send D4, it will be D5. In fact, D4 is a direction. We are saying that command is going from the host to PN532. The D5 says the response from PN532 to the host or the software. 43 is one more than this command we sent 42. 00 is the status, is the success. A successful command gives you 00. Otherwise, you get 01, a timeout, 02. All the list of error codes are very well explained in PN532 user manual. So that's all it is. So what I'm doing in this screen is I'm looking for a response for this command. So only then I say this tag is a ultralight EV1 tag. Now once we do that, the next is all about reading. Sorry, again, in order to run these type of PN532 commands, you must disable this Autopool. Otherwise, after every command, ACR122 will repoll and reactivate the tag, and you lose all the information. So just put in simple words, after you get the UID, just set this to off. This is the command mentioned in ACR122 documentation. So this is the command to set off, and probably when you close this window you can set it on again. The next thing is reading. So you can see all these commands are the APDU commands. I'm not using any PN532 low level commands for reading this. So again, this command is explained in the documentation. This is the standard PCSC command to read. It's called the read binary. You can see here it's a read binary. In fact, this is like a ISO 7816 command. So I try to avoid using PN532 commands in this entire software, so that I can use this with various other reader writers without making more changes. So what I'm doing here is read address 0. So every read command returns you the 16 bytes of data. That is, we know that each page here has got 4 bytes, B0, B1, B2, B3. B0 is the LSP and this MSP. So a single read command will read out 4 pages. So you can see that we have read up to 3FFF up to here. So I'm reading, after that I'm reading the page 4. So you're basically going in multiples of 4. So read page 4, you're again sending this command. So likewise, you read all the pages, and you can also see that by hitting this read tag, I'm also reading the values of the counter. This is just to show the values of the last 3 pages. Now here the command is something different. You can see the read counter, and if you, this again a PN532 command. If you go back to the documentation and look for the read underscore CNT command, it's explained here. This is used to read the counter, and the command structure is the command followed by the address. So if you come across this CRC, you can ignore that, because the reader writer generates a CRC. Now if here the command is 39, the address is from 00 to 02. 00 is counter 0, 01 is counter 1, and 02 is counter 2. And what you get is a 3-byte counter value. So you can look at the response on the right side. It's a data, it's a 3-byte response. And if the read is not successful, you get NIK. So if you look at this command, this is we are sending 39 followed by 00, 39 followed by 01, 39 followed by 02. So in this tag, I can't do any write. However, I can show you how to update the counter, and you can also see what the corresponding command. I'm going to clear this screen, clear it. Probably if you want to take a copy, just right click and say copy paste, clear. Okay, so I'm going to increment counter 0 by 1000 more. So write. Now this is my message, but we'll go and see what exactly has happened here. So I'm sending the command called increment counter. This is this is a raw command, and you can make out the command is it shows it's A5. Let's go here. Sorry, it's increment. Look at the wrong command. It's INCR CNT. Okay, look at this command. So this command takes two parameters. The command itself is A5 followed with the address of the counter. We know it is 000102 followed by the increment value, so which is a 3-byte value, and also you have to be careful with the order in which you send this command. Here you have to send the least significant byte. In fact, sorry, no, it was just wrong here. See, you're going to send 4 bytes here. However, only the first 3 bytes are used, the last byte is ignored. So because it's very obvious that the counters are 24-bit values, so the last byte is ignored. If you go back to the screen, so I'm sending, we know that A5 is the command, 00 the counter. I'm sending 4 bytes, but however the values are only in the first 3 bytes. Only these 3 bytes are used, and keep in mind the lowest byte is sent first, the higher byte next, and the MSB is next. Okay, and immediately after write, you can read it. So I remember reading one of the documentation for NXP about how to use something about the tips about Mifare Ultralight EV1. It says, soon after you increment, try to read the value. If somebody has taken out the tag, obviously these two values don't match. Probably that's a good indication that the increment did not go through. So some of the tips, it's good tip actually. You can do, just try once again. So go to, and I'm going to increase this by 10,000, right? Go to the command here. So we are sending the hex equivalent of 10,000, which is here, and here this time I'm using the counter 1, and what you get is you get a success. Okay, somehow what, here I'm getting 02, but problem ignoring this value, so don't know why I get 02. If you look at, you're supposed to get ACK, so probably that could be, that's the value you get, so you can ignore that for the timing. So maybe I think 02 means no response, because the response is not the actual value, just acknowledgement, and that's probably the reason why the ACR122u is returning 02. So if you remember earlier, I mentioned that the third byte 00 means success, and all other numbers are errors. So sometimes probably this is probably part of my experience, so you can ignore this. We know the counters are written correctly. If you want to check, just I'm going to close it, take out the tag out of the field, and so if you see that the write is still happen. Okay, what will happen if I try to put say I'm going to add, oh yeah, probably this small glitch here. I should have avoided typing so many F's. Okay, so I'm not very sure if this can take hexadecimal. Try to give a big number like this, right? So this is still not big enough to make it through error. Try write again. Sorry, put one more 0. Yeah, so it is returning how this could be an error, so probably that will be fixed in my next release. Okay, so in order to show you how the write happens, so probably I have to use a new tag. So I'm going to place a new tag, and I'm going to a bit of close and try this again. Activate. So read is fine, we know how to read. I'm going to write just page number 4. So call this as say EV1 X. So write. So if you look at the things happen in the background, this is again a standard PCSC command. So this also the ISO 7816 command called update binary. You have to pass the 4 bytes of data to write, and here the actual command starts from here. Sorry, the actual data starts from here. Before that you have to specify the length, and I think these two are the parameters. So this is very well explained in the documentation of ACR122u. So write is successful. So when you do the write for the static logs or the OTP, there's no difference. There's no special command to write to a OTP or a static log. They are still the same update binary, just the page numbers will be different. Let's go and see this. The other command is the ECC command. Now this, the documentation says can be used to verify the originality of this tag. And if you look at the command set, the command sequence is again, this is a PN532 command, and you have to see the command 3C and 00. Look at the documentation, look at this signature. Yeah, this is a signature command, read signature command. So here it's clearly explained what this command is used. Also there is a reference somewhere down where you can verify the signature, and I think to do that you must have an NDA with the NXP. So the command followed by the command is 3C followed by a constant 00, and what you get is a 32-byte ECC signature. So that's exactly what you got here. The next thing about is about the again, see, writing the configuration 0 and configuration 1 is just same as update binary. It's just an update binary command, but however the page number will be used as 16, 17. And also writing to a password, there is no separate password write command or a pack write command, they're still the same. So I'm just going to show you, but I have to remember that. So just make it as A1, B1, C1 and D1. So that's the password. Write, written the password. Look at that, it's just a write. Oh, there are two writes here, write. So it's a write password page and page number 18, and that's what the password is. It's still the same update binary command, and you pass the 4 bytes. So here I'm passing again the lowest byte, higher byte. So if you look at the way the password is entered, when you enter, you always enter the way you write on a paper. The higher command I've written here, MSP, you first type A1, B1, C1, D1. However, when it is saved as the lower byte will be the D1. So this is the lower byte, next byte, next, and MSP. So similarly, writing to pack also is similar. I'm going to write 590. It's hex, sorry. So it's the same thing, but writing to page number 19. So there's no difference between writing to any other pages. So next I'm going to look at the password authentication. Now there's something very important to know here. If you remember, we changed the password to A1, B1, C1, and D1. Now the question is, will this password effective, or will it be effective when you remove the tag and put it again? So let's try that. So I'm going to authenticate with the old password. So authenticate, so authentication failed. So there are some commands in this tag which will be effective only after the next reset of the tag. So because authentication failed, we have to reactivate the tag. Now reactivate. So A1, B1, C1, and D1. Authenticate. Now authenticate, look at the authenticate command. The authenticate command, so it starts from, if you go to the documentation, so probably try for authenticate. So probably it's called as a password, sorry for a delay, password verification. Okay, it's in 10.8. Again, it's very nicely explained here. So for the command, you have to pass the command code 1B followed by the 4 bytes of the password. Here you can see the 4 bytes here. This is the password, and what you get in return is a 2 byte the acknowledgement. So one thing you have to remember here is, so take for example, this is your reader, and this is your tag. Now the reader sends the password, and the tag responds with the pack value. Now in the air outside, the password is available as a clear text, so it's not encrypted. Like if you compare this with the say Mifare classic tag, where the after the authentication all data is encrypted. So probably this is something you have to be aware of. Now the password living out of this reader, it's all in the clear text in the air. So that is how the authentication works. And I think with this video, and probably if you read this documentation a couple of times, you'll be really good in this Mifare Ultralight EV1 tag.